All right, we're going to take a look at handout number 31, problem number 4. And in this problem, we're told that the region that we are rotating starts with x equals 1 minus y squared. And it's also bounded by x equals negative 3. And the axis of revolution is also x equals negative 3. Well, the first thing we need to understand here is what this picture looks like. It's actually not as hard as what you might think. And the most important thing that I want you to do is to do this in terms of y, which means this will be my y-axis and this will be my x-axis, and then we just do everything the same, which means this is just an upside down parabola moved up 1. So it's going to be like that. And since I've switched my axis, that means that this x equals negative 3, instead of being a vertical line, it's going to be a horizontal line through negative 3. So that boundary is right here. And so there's the line x equals negative 3. That is also the line that we're rotating this region around. So we're going to take this region right here, and we are going to rotate it around the line x equals negative 3. So the most important question is, what is the radius? Okay? What is the radius for these circular regions that I am rotating? Well, the radius is going to be this distance right here. Okay? This is my radius. So we need an expression for that. Well, maybe to understand that better, what if, it's probably best to look at a different situation. What if I had a regular old function that was cut off by a line up here, and then I was rotating this around this line right here. Let's say that this was x equals 4, and this was the function x equals, let's say, 8 minus y squared. And I wanted to know, well, what is this radius so that I can figure out, when I rotate this thing, what it's going to look like. Well, I think we can see that this radius, okay, is going to be the entire function value, f of x, and then I have to subtract this piece right here. And in this case, we said that was 4. So it would be the function minus 4. Whatever these function values are, okay, if I subtract the 4 from it, it will always give me this radius. Well, on this problem that we are working with, it works the same exact way. I'm going to take, the radius is going to be equal to the function minus whatever this line was, which in this case is negative 3. Okay, so my radius is going to be the function plus 3. All right? And that is the most important part of this whole problem, because if we do it with respect to y, from this point on, it's actually pretty straightforward. So now if I know that my radius is the function plus 3, now I can plug into my regular volume formula, which is the integral, all right, of the function squared dx. But remember what this function stands for. It stands for the radius. Now, we didn't find our limits of integration yet. The limits of integration are going to come from these intersection points right here. So I need to set 1 minus y squared equal to negative 3 and solve it. So if I set 1 minus y squared equal to negative 3 and solve it, I get that y equals plus or minus 2. So back on my picture, that means this coordinate right here is negative 2, this coordinate is positive 2. So those are my points of integration, or my points of intersection, which are also my limits of integration. All right? So now what we can do is we can go ahead and put my radius in, which we said is the function plus 3. So now I'm going to have volume equals the pi from negative 2 to 2 of, what was my function? Well, it was 1 minus y squared, and then I'm going to add 3. Okay, but remember, that whole mess has to be squared because we're working with the volume of a cylinder, and that's going to be dy. So now I can clean this up. It's going to be the integral from negative 2 to 2 of 4 minus y squared, the quantity squared, dy. All right? So when you square that, you're going to have to use FOIL. So the volume will equal pi times negative 2 to 2 of 16 minus 8y plus y to the 4th dy. And that's what I'm going to integrate, and it's pretty straightforward. You are going to deal with some ugly fractions at the end of this one, all right? But I will go ahead and tell you what your final answer should be. Your final answer should be 512 pi 15ths. Okay, so work through that one analytically. And I'm also going to give you a couple of various answers to handout number 31. In case you want to check your work, the answer to number 1 is 512 pi 15ths. The answer to number 2 is a decimal, which sounds to me like you can use your calculator, 27.203. I already gave you the answer to number 4. Let me skip ahead to maybe number 6. The answer was 2 pi. The answer to number 7 was ugly, 8,192 pi over 15. And I'll give you number 10. Number 10 was 12 pi. And I hope that helps as you work on handout number 31.